Welcome to the DE 24/7 podcast. I'm Brian Albright, the editorial director at Digital Engineering Magazine. I'm here today with Chris Hall, who's the director of software performance engineering at AMD. Chris has a long history in the CAD/CAM space. He started with PTC back in 1992, and he works very closely with AMD's software partners, particularly in the engineering space. Welcome to the program, Chris.
Hi, thanks, Brian, and thank you for having me.
Oh, great. No problem. We cover a lot of new innovations in the workstation space, and in particular, especially over the past couple of years, there have been these incredible improvements in CPU performance. In particular, we've seen the release of these new Threadripper products from AMD. So there are now core counts up to 32 or 64 cores, and that unlocks a lot of capabilities. So I guess to start things off, could you talk a little bit about, for engineers, what's the value of having access to these very high core counts and these new, more advanced CPUs?
Sure, I'd be happy to do that, Brian. Brian, hardware has come a long way since 1992 when I was there working for PTC, and PTC with Pro Engineer at the time really led the transition from CAD as a drafting tool to CAD as something that would enable flexible designs and faster iterations by engineers. But still in the past few years, even though the performance has increased, it really, the focus and the need has been around working with more and more complex models, working with complete assemblies. And that power is there and has been there for a few years, but still CAD has been a tool that requires engineers' intuition in how they design things and a lot of manual work, where 32 and 64 core Threadripper and Threadripper Pro processors come in, and advances in GPU performance is in enabling a new kind of workflow, a workflow where you can afford to take the time, because it's so quick now, to run simulation on your models and really verify and know that the models are going to pass in the field. And then the opportunity to use the new technology of generative design, where the model comes out and it looks completely different than you had in your head, but it exactly meets the requirements in terms of structural load, structural stress, and the way it can handle and work in the model, and at the same time be as light as possible, something that, of course, is very important in the aerospace industry. So that's something that Threadripper Pro has really brought in here to the market. And then it couples that with, on top of the CPU performance, of course, you have PCI Express Generation 4, which enables much faster work with the GPUs, especially if you're doing machine learning and other very data-intensive workloads.
One of the things that we talk a lot about, particularly when we're discussing these new chips, is the value of having these multi-threading capabilities. And, obviously we see that turn up when we're talking about running simulations and doing rendering. But that also extends into other phases of design and even prototyping into manufacturing. Can you talk a little bit about the value of multi-threading in these types of applications and kind of, maybe take us past the types of simulation topics we typically think of when we think about multi-threading?
Yeah, sure. I think it's the production and moving and going towards production is one of the unsung heroes of the design and manufacturing industry, right? You can create the best design in the world. You still need to go and take it and have it manufactured, whether you're outsourcing to a third party and they're just taking the model files and doing everything from generating the P code that's going to drive the CNC machines, or they're working on creating a mold that you're going to use for forming plastic parts. People forget that actually is a very complex process. And there are a number of very complex outcomes as well. When you're going into production, you want to have a process which is fast. You want to have a process that meets your design tolerances and ideally does all of the above with minimal wastage of raw materials. And what multi-threading brings into this space is when you're running a piece of software, for example, like CAMWorks, to take your part and figure out what the optimal toolpath is on the CNC machine, CamWorks is able to process multiple toolpaths in parallel, looking for the optimal toolpath for what you're working with. And the result of that is not that you're going to get things done faster necessarily. I think that the real benefit, and something that we've seen in other industries as well, is you can iterate more frequently. So you've given a budget of 5 days to complete something, or if you're outsourcing this to a vendor, they are including in the cost of per part, or they're including upfront as some NRE, the cost of the engineering time on their side to do the toolpath generation. Well, now within that same time budget, you can get one option, look at it and say, well, can we do better? Let's adjust. Let's use a slightly different set of tools and see if we can come up with something that will produce more parts in a given time period, for example, or is generating or causing less wear on the tools themselves, the cutting tools in the machine. And that means when you buy a system with a Threadripper or a Threadripper Pro, you're going to see an improvement in the cost of your goods and the profitability of the company you're working for.
AMD works with a lot of independent software vendors in the engineering space. Can you explain, sort of the software partner program that you have in place there, and why it's important for the hardware providers and the software providers to work together in concert as we move into these more advanced chips?
Absolutely. Working with software partners is a core function of the team that I lead here at AMD. And, there's that old saying that silicon without software is nothing more than sand. And, it's really true. The thing is, software vendors are looking to solve particular problems for their customers, and they look at a problem from the point of view of delivering a set of functionality and meeting certain criteria. And they're really the experts in their domain. When it comes to deploying their software on different hardware devices or platforms from different vendors, such as AMD, they don't have that expertise. It's really a different mindset to understand how to optimize for a given platform. So realizing this, we at AMD put in place my team and Alliance's team to go alongside it, where we go out, reach out to software vendors, try to understand what the pain points that their customers have and where it is that performance matters to their customers. And I should say that's a really important part of this too, right? Is we take the time to go understand where it matters. It's easy to make something go fast. The question is whether that thing you made go faster is actually the thing that matters to the end customer. So we start off with these conversations with our software vendors, and then we start looking piece by piece within their software and seeing what it is that they're using to take advantage of the technology inside modern CPUs. A good example of that is multi-threading that we've talked about before, of course, but we also have advanced vector math capabilities in Threadripper Pro CPUs, the so-called AVX instructions. And for software vendors, that's often something that's very esoteric and they don't want to get involved with. So we're able to bring our resources in and say, hey, look, we'll just give us some source code. We'll have a look at it and we'll come back with suggestions for you. You can focus on your domain expertise and we will focus on helping you improve the performance on these platforms and take it to another level. There's the level of performance that a customer receives when they first buy a piece of hardware and the current version of the software. And we really aim to deliver improvements in each subsequent generation of that software and improve the ROI for the customer. The interesting thing for us, as we knew that Threadripper Pro was coming to market, we really took the time to go and bring into AMD experts from within the design and manufacturing industry. So a good example of that is we have somebody on staff here who spent more than 15 years working with geometry kernels, the very heart of CAD applications. And the reason we wanted to do that is to make sure we weren't having unreasonable expectations of what could happen. And working with that individual, we've been able to identify some very interesting places for improvements. I will say, design and manufacturing industry, it takes a little while to roll things out. So the other important thing about our approach is we're here for the long term. We're not looking for that quick hit. We're looking for ongoing partnerships. So you'll see continued improvement as time goes on.
Yeah, and we see that over and over again too, as we've watched the software vendors and companies like AMD really feed off of each other in a way and generate these types of capabilities that are fairly unprecedented, I think, in our industry. Along those same lines, we've spent a lot of time here at Digital Engineering covering the developments and the advancements in discrete graphics cards and the GPUs. And we've seen that happen, with AMD's GPU family too. But there are, the integrated graphics and the CPU have also advanced right along with this. And we haven't given it as much attention. So could you talk a little bit about some of the advantages of the integrated CPU graphics for users in this space and how they might make a decision about whether the integrated graphics and the CPU are the best route for them to go, or whether they would be better off looking at a discrete GPU?
Yeah, and I think this is a pretty current topic. In the events of the past year, the move for a lot of people to working from home, one of the things that they've realized is when you're at home and there's no noise of the office around you, suddenly you notice how loud or how quiet your system is. DGPUs certainly bring a significant amount of graphics power and GPU compute power, but that comes at the expense of a pretty high power budget. And as you see, whenever you buy one of those cards, they come with some pretty significant cooling solutions with big fans. But when you're working from home or you want something quiet, and especially if your needs are not so extreme when it comes to graphics, that's where the iGPU can come in. So, a good example of that, we have had a partnership with Lenovo in their workstation notebooks, and there's the Lenovo ThinkPad P14S. The Gen 2 has just come out from that. And that is it's a thin and light engineering notebook platform using our Ryzen 5850 APU and using the Radeon graphics engine, the same graphics engine, the same technology that's used in our Radeon Pro discrete GPU solutions. So since we had the same hardware, all we had to do was talk to our partners over there in Radeon Pro and bring their driver technology. You really need both. You need the hardware that's capable of doing the job, but you need the software that has the pedigree of having been certified for at least a couple of decades now in the design and manufacturing space, and you've shaken loose all the kinks and figured out how to go work with the software vendors. And what this means is you can have a very thin, light notebook with very good performance, probably for small, medium, and even, approaching large models or assemblies, the sort of thing that many engineers find themselves doing. Not everybody is working with the biggest assembly or taking a big picture look at the product that's being developed. And in that case, they reap the benefit of this very quiet experience, something that they can bring with them on the go and be quite happy. And, this is something that has really only been possible in the past few years with the advent of faster memory technology. Something that discrete GPUs always had was wider memory and faster memory. But at the same time, mainstream memory has caught up now, where we're able to offer integrated graphics performance at 4K, for example, something that wouldn't have been conceivable just a few years ago.
Right, and I'm sure our audience is very much looking forward to seeing what they can really do now that this hardware is available, and we're looking forward to seeing what else is going to be coming from AMD down the pike too. As I know you're continuing to work on new advancements.
Yes, we. The funny thing is in the engineering organization that I'm running, of course, we see the hardware that comes out years before it hits the street. And it's interesting to live in the future. It's a very exciting time.
Well, we're looking forward to getting there. Thank you very much for your time today, Chris.
Thank you.
All right. For the DE 24/7 podcast, this is Brian Albright with Chris Hall. Thank you for tuning in, and I'll see you next time.